And how do we start? And I'm going to copy the function here. So this is f of x equals 2x squared minus 5x plus 1. Perfect. How do we start?
Well,
Yes, I'm ready.
we'll start with the limit, but I don't know what we're approaching.
Oh, yeah.
Say it again.
Like, I don't know what the limit is. It as h approaches something, but that's h approaches 0. That's the.
Yeah, we said we're going to use a regular definition with x.
So then the beginning of the numerator would be
Yes.
2 of x plus h minus 5 of x.
It has to be squared.
Oh, yeah, squared.
Very good. Minus 5x plus h and plus 1. Awesome. Minus 2x squared plus 5x minus 1. Do not forget to distribute a negative sign to all three terms. Divided by h. Perfect. I'll continue here, jumping over this. So limit. Very good. Awesome so far. So remember we have to square first. So I put 2 outside. Can anyone give us this binomial squared?
I think x squared plus 2 of x of h.
Very good. Brilliant. Thank you so much. Awesome. Minus 5x minus 5h. Of course, the negative 1 with positive 1 will go away. Then we have 2x squared plus 5x divided by h. Now I distribute. Do not drop the limit operator, please. So then 2x squared plus 4xh plus 2h squared minus 5x minus 5h minus 2x squared and plus 5x divided by h. Yes, these two go away. Yes, these two go away. What do I have to do next? So the first condition was fulfilled. All terms without h are gone. What is my next step at this point?
Factor out the h.
Brilliant. Factor out the h. I couldn't have said it better. Can anyone tell us how many terms and what is left? Brilliant. Thank you.
X.
Yes, awesome. Yes.
H.
Yes, awesome.
Minus 5.
Excellent. So the second step happens as well. Now the third. There are two steps just for the difference quotient, but the third one is for the limit.
Operator. So making that h a 0, I guess.
Excellent. And what is the final answer?
4x minus 5.
Awesome. Thank you so much. So we know now I can copy the beginning and the end. And now remember, we are determining the slope of the tangent line when x is 3. So all I have to find is f prime of 3. Can anyone give us f prime of 3?
7.
So 3 times 4 is 12. 12 minus 5 is indeed 7. So now I have everything I need. I have y minus 4 equals 7 times x minus 3. So very close. Y minus 4 equals 7x minus 21. And I'm adding 4 to both sides. So y equals 7x minus 17. What does this represent? It represents the equation of the tangent line to the graph of y at the point 3, 4. Any questions on this problem? Can we continue?
Could
Okay.
you go back to the other page where you got the y minus 4 from again?
This was
So we
given
had-
to us. This point is
Yeah.
given to us. When x is 3, y is 4.
Yeah, okay.
That was the original
Yes.
equation for the original line.
Yeah.
Not the
Let's take a look. So it says, let's read it together. Find an equation of the tangent line to the curve at the given point.
Okay, so that's the curve and that's the given point.
This is the curve,
Yes.
and this is the given point.
Okay.
So a tangent line to the curve, y, at the given point, 3, 4. Is that okay?
Yes.
Perfect. Let's take a look at a problem with displacement. So let me explain what a displacement is. And then we'll go back there. Page 8. Displacement. Let's suppose we have a particle that starts here and goes to the right for a few seconds, and then goes to the left for a few seconds, and then goes to the right for a few seconds, and stops here. The displacement is the distance between the beginning point and the end point. This is the displacement. What is the distance covered by the particle? This distance plus this distance plus this distance. So this is the distance. The displacement says it started at this point and it ended at this point. This is the displacement. But the distance covered by the particle is this, let's say 3 feet plus 5 feet plus 10 feet. 3 plus 5 plus 10, 18 feet. The displacement will be just the distance between these 2 points, whatever that is. Okay, so now let's go back. So the displacement in meters of a particle moving in a straight line is given by the equation of the motion 1 over t squared, where t is measured in seconds. Find the velocity of the particle. Okay, so when we talk about displacement, we also say it has another meaning, which is displacement can also represent the distance function. So we need this for later. So this is very important, but it can be interchangeably used. Displacement will be this for example, for a particle, and also the distance function. So let's go back. So the displacement in meters of a particle moving in a straight line is given by the equation of motion. So let me write this. Let's say 13. S equals 1 over t squared. I would have preferred S of t as 1 over t squared. Where t is measured in seconds, I always write t in seconds so I don't forget. Find the velocity of the particle at times t equals a, and then t equals 1, and then t equals 2, and then t equals 3. So now let's establish what is the relationship between distance and velocity. So if I am given the distance function, so s of t, distance function, what is the velocity? What does it represent? How do I determine the velocity function? What does it represent?
The derivative of the position.
Yes, because we know that the velocity is the rate of change of distance with respect to time. So perfect, thank you so much. So v of t is s prime of t, exactly. So the rate of change of distance with respect to time is the velocity. Perfect. So then, in order to determine the velocity at t equals a, 1, 2, and 3, I have to determine the function. Once I have the function, I will be able to very easily find these 4 values. But how do I find the velocity? What do I have to determine? You already told me, but please tell me how I should write it then. How do I start?
With the limit.
Yes, brilliant, awesome. The limit of
As h approaches 0.
very good, awesome. What do I have here?
One over t plus h squared.
Excellent, brilliant, thank you so much. T plus h, everything squared. Great job. Okay, good. Next step. There is no need to write 0 over 0. This is the derivative. It will always be initially 0 over 0, of course. What is our next step?
To find the common denominator.
Yes. How do I do that? What is it?
We just write it out as t plus h squared minus t squared.
The denominator cannot be a difference. The denominator must be a product. It cannot be a difference. I cannot write the denominator as t plus h squared minus t squared.
Oh, sorry, t squared of t plus h squared.
Very good. T squared times t plus h squared. Good. Awesome. That's perfect. So now this needs a t squared, and this one needs a t plus h everything squared. Perfect. Excellent. So then t squared minus t, can anyone give us this squared?
T to the second power,
Yes?
2th.
Awesome. And plus h squared. Awesome. Perfect. Remember, this is over 1. I have to flip it. And we are on page 9. Perfect. So that's limit as h approaches 0. The new denominator is h, t squared, and t plus h everything squared. Please do not multiply or expand the factors in the denominator. This has to stay as is. As is. Do not distribute, square, and then distribute anything here. Never. Never in the denominator, please. Do not touch the denominator. Good. So then the numerator will be t squared minus 2th minus h squared. Of course, terms without h must go away. They do. Step number 1 is done. What about step number 2? What do I continue with? What do I have to do
Factor
next?
out the h.
Yes, of course. Factor out the h. And please tell me what is left in the denominator. I'm sorry, in parentheses, I meant to say.
Negative 2t minus h.
Excellent. Of course, step number 2 is gone. And now I'm applying the limit operator, and I can come up with a final answer. Can anyone give us the numerator?
Is a negative 2t.
Excellent. Awesome. Can anyone give us the denominator?
T cubed.
T squared times t squared, t to the 4th. And now, when we simplify, we get this. Perfect. Awesome. We are asked to find the velocity, which is this. So v of t equals s prime of t equals -2 over t to the third. They're asking us to evaluate the velocity at a, 1, 2, and 3. So a, 1, 2, and 3. Can anyone give us these?
VA is just -2 over A cubed.
Of course. V of 1.
-2.
Good. Measurement unit now. Maybe you don't want to write it for A, but the measurement unit. So remember, this was in seconds, and let's check the distance. Meters. Okay, so this is in meters. So what is the measurement unit for -2?
Meters per second.
Yes, it only says that the particle is coming back. It doesn't say that I'm driving. If you ask me, what is your speed? I'm not going to say -2 miles per hour or meters per second, right? It's just that going in the positive direction, the velocity is positive, coming back is giving us the direction. Okay, perfect. For 2, still negative.
-1/4.
Again, meters per second. And for 3 is -2 over 27 meters per second. Perfect. Here's a question. I want to add a question now. I would like to determine, or at least discuss, the acceleration, a of t. What does a of t represent?
Derivative of velocity.
Yes. So a of t is the rate of change of velocity with respect to time, also double prime of t. So the acceleration is the first derivative of the velocity or the second derivative of the distance or displacement function.
Would we literally just